In this video, I'm going to demonstrate factoring by grouping, and if I have some time, I'll get into trinomial factoring. Alright, I didn't give you any notes on how to factor by grouping because really it's an extension of GCF factoring. Because of having an even number of terms, if you look through here, you'll see there's not any number that will divide into all these, and there's no variable that divides into all of them. But if you will look at them as pairs, you will see that in the first pair, you can divide out of x. When I divide x out of these two, I get y minus 5. And what our goal is to be able to get a y minus 5 out of this. Because if I can get a y minus 5, then I can do like we did in the previous example on the other video, and I can factor out the y minus 5s. Okay? So, looking at these two terms right here, which one could I get the y out of? Well, obviously it's this one. And what we need to do is think what I need to divide that by to get y. We're factoring, we have to divide it by something. We're going to divide by 2. And that lets me know what it is that I'm going to divide both of these by. Okay? So I divide this one by 2, I have y. And when you divide this one by 2, you get negative 5. Now you'll see that in both of them, there is a y minus 5 in both terms. So when we factor out the y minus 5, we are left with x plus 2. So it's not as complicated as it looks. It's actually pretty simple. It's just an extension of the thing that we did in the example set 1. Alright, next example. If you look at the whole thing, you find there's not anything we can divide out of it. But if you look at these two right here, I can divide out a to the second. Remember the rule for when you divide by the same base, you subtract the exponents. So this will be a to the first. I'm not going to write well, I'll go ahead and write it. Plus, when I divide a to the second out of this one, they cancel, but I am left with a 2 that was in front of the a squared. Now look at my next pair, and I'm wanting to get a plus 2. Which one will I get the a out of? This one. What should I divide by to get a? A positive 5. And when I divide this by positive 5, I get 1a. When I divide this by positive 5, I get 2. Make sure that you choose something to divide by, even if it was 1, but in this case 5 was the best choice. Okay, in both terms right here, I have an a plus 2, so I'm going to factor out a plus 2. And when I take a plus 2 out of this term, I'm left with a squared. And when I take a plus 2 out of this term, I'm left with 5. Okay. I think another way you can think of this is when you have this right here, you're thinking, what is a plus 2 getting multiplied by? Well, right here it's getting multiplied by a squared, and right here it's getting multiplied by positive 5. So you could say a plus 2 is multiplied by a squared and positive 5. So it kind of goes back to our multiplying thing we did. Remember, I told you factoring is the opposite of multiplying. So it goes back to what we did on our multiplying lesson, where we said everything over here had to be multiplied by everything over here. Well, what was a plus 2 multiplied by? A to the second and 5. Okay, enough talking. We'll go on to the next problem. What can I divide out of the first pair? Y to the second. And when I divide a y to the second out, I'm left with x squared plus 3. Now I look at the next pair. I'm wanting to get x squared plus 3. Which one would I get x squared out of? Well, obviously this one. What would I have to divide by to get x squared? A negative 5. So negative 5 is what I'm going to divide both of these by. Now, if we divide by, the thing we need to get the x squared, and we don't get x squared plus 3, then this factoring by grouping won't work. The expression would have to be prime, meaning that you can't factor it. Alright, anyway, negative 5 into negative 5x squared is x squared. And negative 5 divided into negative 15 is positive 3, just like we wanted to get. So I'm going to put these, I'm going to group these together. In both of them, there is an x squared plus x squared plus 3. And what was x squared plus 3 multiplied by? Well, right here it's y squared, and right here it's negative 5. In the next example, you see there's 4 terms, nothing divides into all of them, and so I'm going to take them by pairs again, just like we did previously. I'll write in black this time. And the first pair, what can I divide out? I can factor out a p. And when I factor that p out of this, I end up with a q and a positive 3. Now look at the next pair, and I want to get a q plus 3. Which one will I get the q out of? It will be this one. What would I have to divide that by to get a q, a positive q? Negative 1. Because I divided this by negative 1, I'm going to divide both of these by negative 1. When I divide this one, I get positive q. Thinking this is what I wanted. When I divide this one by negative 1, I'm going to get positive 3. And you see this matches identically with what I have over here, q plus 3. Both terms have q plus 3. And what is q plus 3 multiplied by? Well, when I divide q plus 3 out here, I get p. And over here, I have negative 1. So pq plus 3p minus q minus 3 is equal to q plus 3, that quantity, multiplied by p minus 1. Okay, now we need to discuss trinomial factoring. And, trinomial factoring is probably one of the biggest, most important skills that you need to learn for college algebra, because we use trinomial factoring so much. I've broken it into 2 sections. One section is where we're factoring trinomials that have a coefficient of 1 in the middle. In the front. A leading coefficient of 1. So what that looks like is this right here. X squared, it'll be 1x squared plus some number times x plus a constant. Okay? And when we factor it, our factors are going to look like x plus some number and x plus some other number. And to find out what the 2 numbers are, we have to think about what 2 numbers would multiply to give me c, the number in the back, and what 2 numbers will add together to give us b, the number in the middle. And these have to be the same numbers. Okay? So I think what I'll do is I'll work an example just so you can see what I'm talking about. And then I'll come back and we'll talk about factoring trinomials that don't have a 1 in the front. Okay? But first we're talking about ones that have a coefficient of 1, a leading coefficient of 1. In the third example 3, in the third set of examples, the first example is x squared plus 5x plus 6. You see it meets the condition of having this 1 in the front. Okay? So we know that factors are going to be x plus something in the first parentheses and x plus something in the other. Now I'm hesitating about putting the plus because these numbers may be negative, and if they were, I'm going to put a minus whatever. You'll see that when we do this example below. Okay, so first example. I have to think of 2 numbers that multiply to give me 6, but that add here, I'm going to do this a little bit differently. But to add to give me 5. Okay. So, for example, if I thought, okay, 1 times 6 is equal to 6. Well, does 1 plus 6 equal 5? No. But if we say 2 times 3 is equal to 6, then 2 plus 3 does equal 5. And so these are my two numbers. These are the numbers I'm going to put right here. And if you was to do x times both of these and 2 times both of these and combine your like terms, you'll get this expression right here.